Alright, so in this video we have the moon as the mass exerting the force and a satellite in orbit around it that is experiencing the force. So the first thing you have to do when doing this problem is that we know what little m is over here, but we have to look up the mass of the moon, which I have written here. So you'll notice in Blackboard there's some links in the left-hand menu that link to constants tables and stuff like that you will have access to for the exams, just like your equation sheet. Now in the problem we're given the altitude, and remember altitude is the distance from the object to the surface of the planet. So this would be the 100 kilometers provided in the problem. So you also have to look up then the radius of the moon, because r is going to be the radius of the moon plus the altitude. So you see we're using our gravitational force equation here. I plugged in the gravitational constant, the mass that is experiencing the force, which is the satellite, the mass that is exerting the force, which is the mass of the moon, and then the distance from center to center, which is going to include both the radius of the moon and the altitude. Now, when you're working with this equation, we have to be very, very careful of the math. Now notice here I've done the numerator and then the denominator, and then I've divided here. If you're finding that you're not getting this answer, but you're getting the same numerator and denominator as me, make sure that when you type this in the calculator, you put it in parentheses, because you may be dividing by the 3.39 and then multiplying by the 10 to the 12. So it's something you have to be very, very careful of when working with this equation, because you're working with some very tiny numbers, some very big numbers that you are using parentheses, so you don't end up multiplying by something you intended to divide by. Now, to answer part B of this question, we have to look at the different perspectives. So the moon is going to pull the satellite towards it. So the force from the moon on the satellite is going to be towards the center of rotation, as seen from the satellite. But the satellite is going to pull the moon in the opposite direction. So the force from the satellite is going to be equal but opposite. So this is Newton's third law. If the forces were not equal but opposite, opposite meaning in the opposite direction, the satellite and the moon would be pulled towards each other or pushed away from each other, because there would be a net force or acceleration in one direction or the other. So in order for the satellite and the moon to remain in that configuration, the force must be equal but opposite. And I know that seems counterintuitive because the moon is much larger than the satellite, but according to Newton's third law, the forces are going to be equal but opposite.